morning, everybody. Today I'm going to talk about the quality as it pertains to a certain area of botanicals. We're talking about essential oils. As you all know, essential oils are a very important topic. They're found in foods. They're in foods for flavor. They impart odor. They're used in medicine and also as a preservative. You'll see them in consumer products, aromatherapy products, fragrances, cosmetics, home care, laundry, personal wash products. And I'm not going to address any particular sector. I'm going to talk about essential oils in our testing for quality. As mentioned earlier by my other colleagues here, these are ingredients and they tend to be rather costly. Now, the quality can vary for a number of reasons, even at the best of times. They can vary from the fact that during the harvest season, the earliest part of the harvest season may have a somewhat different set of components compared to later in harvest season. The part of the plant, maybe during the harvest, let's say the leaves are picked. Maybe sometimes the leaves are picked and a little bit of the stems come with, a little bit of the woody part of the stems. That can affect your quality. The processing, where you are in the processing can affect it. Geography, as mentioned earlier, can affect it as well. And storage and shelf life. How long has it been sitting around? Trading hands before it got to you. Another aspect I'm going to talk about is fraud. So why do we want to do all these things? Why are we even worried about quality? We're worried about quality because we want to be able to establish what it is we're handling. We want to be able to maintain that quality for the flavor, for the odor, and because there's also a component of safety, depending on your industry. So we're going to talk about now, we take a plant and we're going to isolate the oil from it. So that's how we're going to talk about now, our essential isolation. And techniques can differ. We can have distillation, where we could steam could be used, hydrodistillation, distillation by solvent extraction. These will have different effects upon the final product. We can use simple extraction using a liquid. We can use wax. Wax can, sometimes you'll see it being used to make it concrete. You can have another popular technique is supercritical fluid extraction. You'll see it with CO2, sometimes with Freon. And there's some newer ways of doing extraction, some more gentler microwave assisted extraction for larger materials and botanicals. The physical form these materials are going to take is important. It'll be usually we're talking about liquids, but it could be an absolute, which is processed a little bit differently, or a concrete. Now, the number one thing about all these products are they're not single chemical substances. They have multiple components, and we're going to analyze and determine our quality by those components. Okay, and we're going to talk about some advanced techniques on how to do that. In particular, we're going to talk about near the end, advanced technique of the chirality of the molecule and of isotopic effects. So, first part here we have is the characterization methods, and you see it all through the morning. We need to be able to compare your essential oil to a standard, something you know to be true. Now, there's many ways of obtaining that. You may go to the source, you may collect the plant, you may bring it back to your laboratory and extract it, which is a fun thing to do. You may have it sent to you already prepared. Your company may already have an internal standard that they've trusted and believe to be correct, or there may be written in a book just various numbers. So you maybe want to step up your game. And there's a couple of ways of looking at this. One of them is ISO, and that's an internal organization for standardization, and that's a federated organization internationally, where they spend time figuring out the best way to analyze something, agreeing upon it. It's tested, it's reproduced, it's repeatable, and these methods then are put together called method, and they're published. Here in the U.S., ANSI is part of that group. For essentials, a very important group is AFNAR, coming out of France. They're part of the group. Sometimes you may use a national pharmacopoeia, which was mentioned earlier today. And the national pharmacopoeia could be from U.S., could be from England, Germany, China. But this gives you an idea of where your method is going to be coming from, and you want to know where they're coming from. Now I'm going to spend a little bit of time talking more about certain types of methods. I'm talking about the ISO methods for botanicals. All right. Usually you'll see various characteristics in a method. This goes back to the idea of a toolbox, that you're going to have a variety of tests you're going to use to find out if your essential oil is of good quality or not. Some of the tests will be physical in nature, like the relative density, refractive index, optical rotation, miscibility. I'm not going to get into all these things. We'll be here all day. Okay, some of the chemical tests you could use would be an acid value. You also use a sensory type method, which would be color and odor. And odor is a very effective tool to be used in combination with others. I'm going to spend a couple more slides here on the chromatographic profile. As we've seen a little bit of that earlier today. Now I'm going to specialize on the chromatographic profile. I'm going to talk about gas chromatography, and another area is high pressure chromatography. You can use other advanced analytical techniques. You could use NMR, elemental analysis. Elemental analysis is becoming very popular now due to the trace of heavy metals in soil. The newer technique is infrared spectroscopy. Now in the gas chromatography, you may see FID being used, and that's the standard that's used for setting up a method. But I'm going to go into a little bit more, especially when it comes to adulteration, using mass spectroscopy. Another new technique, I shouldn't say new, but modern technique is isotope ratio mass spectroscopy. And here is olfactometry, which is again the ability to separate a material and then use your nose to detect it, or use electronic nose. Once we get these methods in place, we're going to be able to see if it's authentic or not by this method. Now, again, we're going to rely on a physical standard, okay, and it's going to be of known purity, and you're going to have it fully identified, you're going to have a method, you're going to use it, and we're going to talk about the ISO methods. Another good thing about authentication is using GCMS in combination. You may use a chiral column to get further information, and then we're going to talk about IRMS. And here's a little cartoon of a gas chromatograph. Okay. Now this is very simply said: is that the sample is in a liquid form, is injected into a column, which is kind of like a picture, like a straw. It's moving through a straw. It's heated to the vapor state, and these materials are going to separate, and then you're going to use a detector to detect them. It's very simply said. So an ISO method uses a detector, an FID. We're going to add in a GCMS. Give us two ways of detecting it. We may choose to change the column to a chiral column to get even more separation. So all these techniques could be used to achieve a very good authentication of the material. Okay, we're going to change gears a little bit. I'm going to have you guys help me figure something out. Okay. Here is a sample. This is our standard. We have two standards on top of here, all right? This is a gas chromatogram. This was made using an FID. This is what the ISO protocol is built upon. Here we have a sample of sandalwood East Indian, okay? And here's one of sandalwood Australian. Here's where I need your help to help me figure out something. Here's a sample, okay? Sample one. This is, someone says this is a sample of sandalwood East Indian, all right? So using nothing other than the pictures on the screen, think of these as being like photographs you've taken, okay? Think of, here's Las Vegas, you know, here's a Luxor, here's our hotel. This looks like New York City. That's all you got to know, okay? I'll do the heavy lifting. Just help me with one piece. So here's our sample one. I ran the exact same way. I ran the other two. Which one is it? Does it look like that one or looks like that one? Right? Looks like East Indian, right? Falls right on top of it, right? You have these couple little peaks here, a couple bigger peaks here, okay? You've now become technicians. You can now use the ISO method to figure out, is this sample good or not? Is the quality there? You can now set a specification against this. We're going to go a little bit further. We're going to use a GCMS. We're going to use that instrument to tell us that these three little peaks here are various santalene peaks. Okay? We're going to look here, and this is going to tell us these are various santalol peaks. These are somewhat unique to sandalwood. So we further authenticated that this material is good. Okay? Now we're going to use this picture over here now. Okay? This is sample 2. All right, you guys ready? Looks a little bit different, right? You look at this, has a bunch of peaks over here. These look familiar to you. And I don't know what that mess over there is, right? This doesn't match either one of these, right? Well, I was given these samples to analyze, okay? And no, this is a no. This is not match specification. There's something very wrong here. When I investigate this, I find out there's propylene glycol in the sample, right? So sandalwood doesn't contain propylene glycol. So it looks like we may have a case of adulteration, right? It shouldn't be there. To further make it more interesting, over here there's this foreign matter, okay? So you put this foreign matter actually is a perfumery ingredient that smells like sandalwood. So what someone did was somebody went ahead and added propylene glycol to get more volume, have more stuff to sell, or maybe it didn't smell that good to begin with. Then they added a perfumery ingredient that smells like sandalwood, hoping that when all got put together, it would smell good and they could sell it. Didn't have to get all fancy about it, right? You guys can do it, right? You can see it plain as day. It don't match. It doesn't match either one of them. It's adulterated. Okay. But we're going to talk a little bit more about how to identify, how to go from a simple blip on a screen to being able to figure out what it truly is. Okay, we do it by using gas chromatography. This will be a tool that you'll be using in your toolbox. Here's a chromatogram. Again, just blips on a page. We use a library that has a fragmentation pattern. Take a slice here. It takes a little slice, and that's it down below. Has these little peaks all over it. Okay. I go ahead and look at this fragmentation pattern. Using library references, we can identify what it is, and that's xanthol. So we know it's there. So the mass spec is able, by looking at the mass, tell us more information. Now we're going to put it all together. Okay, this is the information we're going to use to set your specifications with. It's just this easy. Here we have all the little peaks that came out, and they're numbered. The retention times, that's important. We're going to use that for our retention orders, we call it. We're going to have the amount. So this is for sage, by the way, which there's a different example now. This is just sage. Could have picked anything. This has to be for sage. So if ID, we're going to know the name of it was supposed to be to begin with. We're going to compare it to a standard. We're going to look at our component. Our components are going to be in there. There's a retention order, and there's the amount. Now, by mass spec, we're going to be able to take these peaks and figure out their names by using our library. Now, the ones in yellow are referred to as crucial for identification of the raw material. So we have alpha-pinene, camphene, beta-pinene. These all are important pieces to what makes sage sage. There's different varieties of sage out there, and these will have some variation, and that's okay. Another more advanced technique that is readily available and can be used and is quick is changing the column in our GC to our chiral column. Okay? This is a rapid tool for authentication of samples. The earlier sample came into the laboratory, and the work was done in 2 days. That's how long it took. This takes a couple more days to do chiral chromatography. And here we'll take a look at pinene. Here's pinene. Nice little chromatogram of pinene. We take a chiral column, run it through. The alpha pinene splits. This is for orange oil, by the way. This is for orange oil. So here it's split. The pinene is split into two different peaks. These peaks are beta pinene minus and beta pinene plus. You're like, Justin, what are you doing on this screen? Let's talk through a little bit here, okay? This, like the chiral column, is able to separate this beta pinene because beta pinene itself is chiral. So what does chiral mean? Chiral means that there's different substituents on a carbon atom. Look at your hands once, right? You have two, you have a left hand and a right hand, right? Everybody does, right? So look at your hands. Your hands are chiral. It's not just a hand, it's a left hand. It's a left hand, it has an arm here, a head here, your body's here. For this hand, the head's over here, the body's here. So it's a spatial arrangement. They're mirror images. They're not the same, but they're mirror images. And that makes them chiral. And the column being chiral as well, this work was done with a beta-cyclodextrin column. It's able to separate these two. And you can see here's the two molecules we separated. You can see they look like mirror images, don't they? Don't they kind of look like a mirror if you're a mirror right through the middle? Right? Okay. So very quickly, we're able to authenticate our samples if we have the proper methods. Another interesting technique is isotope ratio mass spectroscopy. That's a very advanced technique. It's for interesting technique. It takes advantage of a quality of atoms that we don't used to have to do. We have to do this work because people keep on committing fraud. So that's why this was really developed. And it looks at the carbon, hydrogen, oxygen, nitrogen of atoms, it can be used. You don't have to use mass spectroscopy to take advantage of the isotope effects. You can also use NMR. It's a very effective tool. It's rather it's been around a bit, still being developed, but it's there for citrus soils in particular. It's good for. Not good for. It's well known for. So these little things I mentioned, I want to put all together for you in this one simple slide. The idea of certification tools for authentication. Okay. The first one here we have. I didn't talk about much of the accreditation of your laboratory. Laboratory doing the work, okay? It's not going to be this paper push around. It's actually a laboratory going to be doing the work. You want to make sure the laboratory has the tools they need. You're going to know that by looking at the method. You just ask them, say, do you have any accreditation? One of the accreditation bodies is ISO again. ISO accredits laboratories. There's other accreditation services as well. I just want you to be aware but accreditation is a good thing to have. You want to employ analytical methods that are specific to your essential oil. One type of method doesn't fit all. Okay, there's no cure-all in this. You want to have intimate knowledge of the essential oil that you're working with, right? You want to maintain your reference standards. So the laboratory will be an important piece of this. You want to look at the physical material. You want to look at your database. You can look at published articles. So you would expect to have a library of essential oils for the materials you handle. You may want to set that up by having someone take the plants, extract them, and keep them in your facility. For the chronographic piece I showed you, you want to build that, again, for essential oils. You want to make sure all your components are identified by the techniques you want to use. You're going to take all this information you're gathering, and you're going to store it electronically into a database. You can have in there such things as the retention time, the amounts. You may have isotopic abundance. Another piece that we're forced to have now is you want to be able to keep a list of, list of adulterants which are been found to be in essential oils. Okay, the people who commit fraud are really clever, and they're going to go out of their way to examine the various methods and see if they can't get around them. So you want to have a list. And when you're all done, you're going to have a certificate of analysis made. Okay, in your certificate, when you see the certificate, you want to make sure, what does it say? You want to make sure that it has a unique identification, the botanical name, the method, the name, and the various details that tell you that it's done a certain way. That's all. Thank you much, and enjoy the Congress.